Hello everyone, I am Dr. B. Vijay Babu. Today I am going to discuss about DMA. DMA stands for Direct Memory Access, and it is one of the important mode of I/O data transfer in I/O organization of computer organization architecture course. This DMA method allows an input-output device to send or receive data directly to or from the main memory, that is RAM, bypassing the CPU. So this is to speed up the memory operations. So the DMA process is managed by a special unit known as DMA controller. That means here the role played by the CPU to transfer the data is now played by the DMA controller. As we can see from the diagram, the DMA controller unit which is placed between the CPU and the I/O device serves the purpose on behalf of the CPU. So we may get a doubt naturally, that is, if DMA controller does everything, then what's the role of CPU in this DMA? The answer is simple. In DMA, the CPU plays the role of a facilitator or arranger of bus system to DMA controller. That is, originally the bus system is under the control of CPU or the processor, and whenever the controller initiates the data transfer, then the CPU facilitates the bus system, and after the completion of the transfer, the bus system is handed over back to the CPU. Before we get into the details of DMA, let us see the three important I/O data transfer modes to transfer the data from the I/O device or peripheral device to CPU or the main memory. They are, the first one is programmed I/O data transfer. The second one is interrupt driven or interrupt initiated I/O data transfer. The third one is, which we are going to discuss now, DMA, which is direct memory access. In the first method, programmed I/O data transfer, the data transfer is initiated by means of a program. That is, the CPU continuously monitors the status of the flag bit present in the status register, whether it is 0 or 1, and then starts initiation of the data transfer from the I/O device. In interrupt driven or interrupt initiated I/O data transfer, the entire data transfer is initiated by means of an interrupt. That is, whenever an I/O device is ready to transfer the data, it issues a signal called as interrupt signal to the CPU, stating that it is ready for data transfer. So here the CPU, which is already doing some activity like executing some instruction, is actually interrupted by the I/O device with a request to initiate the data transfer, but more than one device may try to interrupt the CPU at the same time. In this situation, we have to follow a priority based method to service a particular I/O device. When the CPU senses an interrupt signal on the interrupt request line, CPU stops its currently executing task and respond to the interrupt sent by the I/O device by passing the control to interrupt handler. The interrupt handler resolves the interrupt by servicing that particular I/O device. The concept of defining the priority among the devices so as to know which one is to be serviced first in case of simultaneous requests is called priority interrupt system. This could be done with either polling mechanism or the daisy chaining mechanism. In polling mechanism or polling method, it is a software method, and a daisy chaining method is a hardware method. Polling refers to the situation where an I/O device is repeatedly checked for the readiness, and if it is not, the CPU or the processor returns to a different task. Coming to daisy chaining method, it is a hardware method that involves connecting all the devices that can request an interrupt in a serial manner. This configuration is governed by the priority of the devices. So the device with highest priority is placed first, and it is going to be checked first, followed by the second highest priority device, and so on. The third important method is DMA. In this DMA, the data is directly transferred to main memory without the interference of CPU. That means CPU just plays the role of a facilitator or arranger of bus system. Let us try to understand how DMA transfers data from I/O device to memory. We can see from the diagram. Here it consists of various pins like DS, RD, BG, and so on. So DS is used for device select, interrupt, RD for reading, BG for bus grant, and BR for bus request activities. When the CPU initiates data transfer from I/O device to main memory, the CPU instructs the DMA controller to handle the task. The CPU will ask or then forget about this operation and proceed with other tasks. When the DMA controller has completed the transfer, it will signal the CPU using an interrupt. Thus, the CPU will conclude the task needed associated with the data transfer it initiated. So, the DMA request line used in this particular DMA controller requests the DMA transfer. The bus request BR signal is used by the DMA controller to request the CPU to relinquish or release the control of the buses. The CPU activates the bus grant output to inform the external DMA that its buses are in high impedance state so that they can be used by the DMA transfer. So the address bus is used by the address of the DMA controller and memory is at given location. The device select and register select lines are activated by the addressing the DMA transfer. Now the RD and WR lines are used to specify either the read or write operation on the given memory location. The DMA acknowledge line is set when the system is ready to initiate data transfer. The data bus is used to transfer data between the I/O device and the memory. When the last word of the data transfer or the DMA transfer data in the DMA transfer is transferred, the DMA controller informs the termination of the transfer to the CPU by means of the interrupt line. So this is how the DMA works to transfer the data from an I/O device to the main memory. Thank you.